Welcome to the Explainer. Today, we're going to talk about something that's, well, it's pretty much invisible. It's this incredible engine working silently behind basically every single app, website, and service you use. And its whole job? To prevent total, utter digital chaos. I mean, really think about it for a second. How does your favorite online store handle millions of products? Or how do social media apps keep track of billions of posts? Your bank, how does it manage countless transactions without messing up? To really get why this isn't all just a giant mess, we have to imagine what it would be like without the system that makes it all work.
So let's say you're building a simple blog app. In the very beginning, you might think, hey, I'll just store my data in a few simple text files. You know, one for users, one for posts, another for comments. Seems easy enough, right? For a tiny little blog, it works for a little while. But this simplicity, it's a total trap. Because the second your app starts to get even a little bit popular, this whole system it completely shatters. A user changes their email? Uh-oh, now you've got to go digging through every single file to update it by hand. What if two people try to sign up at the exact same time? Boom, the file gets corrupted. Trying to find all the posts by just one author? Get ready to slowly scan through millions of lines of text. And the absolute worst part? If the power flickers while you're saving something, poof, that data is just gone. Forever. Look, this isn't just about being inefficient. This is downright dangerous. The system can't scale, it's begging to be corrupted, and it's painfully slow. It's not a question of if it will fail, but when. It is, in a word, digital chaos. Okay, so we've established the problem. It's a total mess. But out of this chaos comes a really elegant solution. Engineers looked at all these problems and designed something specifically to fix them, the relational database. Let's dive into how this thing brings order to the mess. So, a relational database is nothing like that messy pile of text files we talked about. A much better way to think about it is like a perfectly organized, maybe even an infinite, office filing cabinet for your data. Every single piece of information has a very specific logical place where it lives. And this filing cabinet analogy really helps make the whole concept click. So the entire database, that's the filing cabinet itself. Each table, like one for customers or another for orders, that's like a drawer in the cabinet. And inside a drawer, each row is like a single file folder for one specific customer, customer number one. And then the individual pieces of info inside that folder, like their name or email, those are the columns. But here's the real magic, the part that changes everything, the relationships. This is how we cross-reference information between all the different drawers. And this is where that magic really kicks in. So in our bad text file world, every single order would have to store a copy of the customer's full name and email. Imagine they update their email. You'd have to go find and fix hundreds, maybe thousands of different orders. It's a nightmare. But with relationships, the order doesn't store the email. It just points to a unique customer ID. So when that customer updates their email, you change it in exactly one place. And poof, every single order they've ever made is automatically up to date. No duplication, no mistakes. It's a game changer.
All right, so we've got the organization problem locked down. That's a huge win. But what about speed? How does a database sift through billions of records to find what you need in milliseconds? Well, this brings us to its first real superpower, the index. Okay, imagine you've got this massive 1,000-page textbook, and you need to find every single mention of the word PostgreSQL. Without an index in the back, what do? Well, you have to read every single page. It would take you an hour, maybe more. But with an index, you just flip to the back, look up PostgreSQL, and it tells you exactly which pages to go to. 5 seconds tops. A database index works in the exact same way for your data. And we're not talking about a small improvement here. This isn't like making something 10% faster. The difference is absolutely staggering. We're talking about searches that can be over 700 times faster. That's literally the difference between a web page taking an entire minute to load versus appearing instantly. It's night and day. Now, the key here is you have to be smart about it. You don't just put an index on everything, because that can actually slow down the process of saving new data. Instead, you place these super powerful indexes strategically. You put them on the columns you search all the time, like an email address, or on columns you use to connect tables together, or on columns you sort by a lot, like price. You get maximum speed right where you need it most. Okay, so we've got order and we've got lightning speed. That's awesome. But what about that other terrifying problem we talked about, the one where a system crash just destroys your data? For that, we need to look at the database's other amazing superpower, the transaction. Let's go back to that scary bank transfer scenario.
Imagine the system is moving money. Step 1. It subtracts $100 from your account. Success. But then, right before it can add the money to your friend's account, the power goes out. The system crashes. So what happens to your money? It's just gone. It literally vanished into a digital black hole. Terrifying, right?
Okay, now let's replay that exact same scenario, but this time with a transaction. A transaction basically wraps that entire operation, the subtraction and the addition, inside a protective bubble. It makes a simple promise. Either all of these steps complete successfully or none of them do. It's all or nothing. So if every step works perfectly, the database commits the changes, making them permanent. But if any step fails, if that system crashes halfway through, the database automatically rolls back. It undoes everything. The money is safely back in your account like nothing ever even happened. This concept is so incredibly important. Forgetting to use a transaction for any operation that involves more than one step is one of the most classic and, frankly, most dangerous mistakes a developer can make. You're basically just leaving the door wide open for your data to get corrupted. This all-or-nothing guarantee is the first part of a set of 4 promises that a good database makes. It's an acronym called ACID. The A is for atomicity, that's our all-or-nothing rule. The C is for consistency, which just means the data always has to follow the rules you set for it, like you can't have a negative bank balance. I is for isolation, making sure that if 2 transactions are happening at the same time, they don't mess each other up. And finally, D is for durability. This is a big one. It means once the database tells you your data is saved, it is saved. It'll survive a power outage, a crash, anything. It's locked in. So, after all that, let's take a step back and look at the big picture. We started this journey in a world of pure digital chaos, but we've seen how the relational database brings order, speed, and safety. So what does this all really mean for us in the real world? Well, this is how it all comes together so beautifully. Remember that chaos of having to do manual updates everywhere? That's solved by relationships. That painful frustration of super slow searches? Totally eliminated by indexes. And that absolute disaster of data getting corrupted? Prevented by transactions. For every single problem we started with, the database has a specific, elegant solution. When you boil it all down, relational databases are really the invisible backbone of our entire modern digital world. They provide the structure we need to manage mind-boggling complexity, the speed to get us information instantly, and the safety guarantees that let us trust these systems with our most critical data, from our family photos to our bank accounts. You know, they're a perfect example of one of these incredibly complex, truly elegant systems that are working silently behind the scenes all the time. And it kind of makes you wonder, what other invisible engines are out there, quietly making our modern lives possible?